SureBuild is a technically advanced construction method precisely engineered from cold-rolled galvanized steel to meet the exact specifications of the architect's design. Through computer-aided design software, CAD, the frames were recreated on screen from the original Mega 5 drawings. The CAD system also provides vital technical information which enabled the frames to be manufactured in sections to the precise tolerances and requirements detailed in the original drawings, even down to the location and punching of holes for services such as heating, plumbing and electrical wiring. At the Oxford Brookes site, the foundations and ground floor had already been prepared using 1.5 metre deep strip footings and a cold-formed steel G-section to form an accurate template for the wall frames and to support the suspended ground floor. Steel decking was placed between the G-sections and the in-situ concrete was levelled using the G-section as a tamping rail. The steel-framed sections, which can easily be carried by 2 men, thereby eliminating the need for on-site lifting gear, were offloaded, ready for erection. The first frames were located on the G-section at the corner of the building and bolted into place. The remaining frames were then sequentially positioned around the perimeter of the foundations and fastened together before being aligned, levelled and secured to the base slab. Once the ground floor frame had been completed, lightweight steel floor joists were then installed and weather-resistant flooring was fastened to the joists. A floating floor was used to provide a high level of acoustic insulation. As with the ground floor, frames were then secured at the corner of the first floor, and the process was repeated. In the case of the Mega 5 project, 2 alternative roofing structures were used: an open-roof lightweight steel truss system and a purlin-based roof of Z sections spanning the cross walls. In both cases, a high-insulation roofing panel was fixed to the steel sections, which supported both the battens and the roof tiles. Once the lightweight steel frame had been fully erected, taking only 2 weeks to complete, twin-layer insulation panels were then secured to the exterior of the frame. This form of insulation typically achieves U values of 0.2 in the walls. The insulation provided a weatherproof building envelope which allowed internal trades to commence work. This warm frame technology ensures that condensation does not form on the frame in service. The external brick cladding was built conventionally and held in place by stainless steel wall ties. The internal plasterboard used in this project is 12 millimeters thick, satisfying the building and fire regulations of 30 minutes fire resistance. The prefabricated staircases to all floors in the apartment block of the building were constructed with steel treads, risers and balustrades. The construction program, from laying the foundations to handing over the building, took only 16 weeks, and the conclusions drawn from this stage of the Mega 5 project is that lightweight steel framing offers considerable benefits to the house builder. Flexibility in design to reflect individual tastes. More usable loft space, adding value to the property. Speed in construction, saving money and time. Fewer callbacks, as steel does not warp or shrink. More reliable building program, as steel is not affected by on-site weather conditions. The frames are pre-engineered to exact specifications for easy on-site erection. And of course, steel is one of the world's most recyclable materials.